Hello, Tom again from Every Step Calculus, everystepphysics.com. This is a kind of an interesting problem regarding the Felix Baumgartner leap from a high altitude balloon. And you can read it here. Actually, I'm showing you how I find free fall velocity and elapsed time in my programs. And physics to get to my main menu. I'm going to scroll down here to planets, because this deals with planets. To the P section. There's planets. And when they have an arrow here, you see this arrow, it means that there's more in the menu. So you go down and here's free fall for Earth, because it's a free fall problem. And we're finding velocity. We could find acceleration or the height with acceleration, but we're going to find velocity here. We're going to enter the initial height now. Notice, let's read this. Felix Baumgartner is an Austrian daredevil and skydiver. He made a leap from a high-altitude balloon capsule 24.2 miles above the Earth on October 14, 2012, age 43 at the time. He broke several records for free fall, one of them velocity, fastest human free fall, 833.9 miles per hour, highest skydive, highest manned flight in a balloon, and the first free fall human to break the sound barrier, 761.2 miles per hour. Here are my Every Step physics programs. Like if installed in your TI-89 titanium calculator, just like that, demonstrate the power of my programs for solving hundreds of physics problems, in this case a free fall problem, finding velocity in elapsed time. So the initial height is 24.2 miles up above the Earth. We're going to press alpha first, put 24.2 here. And I do conversions, and you know, they never know what they give you in a physics problem. Here it's miles. Excuse me. And so we solve that to meters. Everything is in meters or kilograms in physics formulas, as you probably know. There's the meters. Give you a chance to change it in case it was wrong, but it's correct. We're going to enter the height that we desire. In this case, I'm going to put 20 miles in there because 20 miles is close to where, very close to where the drag of air gets involved with his free fall, and he gets up to this free fall velocity or speed of 833.9 miles per hour, and then starts to drastically reduce the speed because of the air drag on him. I don't know why. I've tried to figure out why his arms weren't ripped off at those kind of speeds, because obviously even a 120 mile an hour hurricane really does some damage, you know. So I'm still researching that, and you can research it too and let me know if you find anything. But anyways, let's do it here. We're going to put 20 miles in here, alpha 20, and miles. And here's Newton's formulas, or not this one, but coming up will be one Newton's theories, etc. You subtract the final height from the initial height, come up with 6,700, and then we do the formula. Final velocity squared minus initial velocity squared equals 2 times the force of gravity minus the calculation for final minus initial height, okay? And so then we do more algebra, come up with this. We transpose the initial to the other side here, and here's the calculations, okay? Turns out at 20 miles he's doing 814.61 miles per hour, or 364.16 meters per second. And then the elapsed time would be this calculation and formula here. Final velocity divided by the gravity of Earth, 37.122 seconds. Pretty neat how every step physics.com. Go to my site, buy my programs, and pass physics. Good luck in your classes. Have a good one.